Hi everyone, this is Kiranmai from HNS department. Today we are going to have a look on GP Thomson experiment, which is an experimental proof for the existence of matter waves. GP Thomson is a scientist who performed many more experiments with the electrons, which are accelerated to a very high potentials of 10,000 to 50,000 volts. In his experiments, he observed some diffraction patterns and he calculated the wavelength for those electrons also. Now, in this experiment, the experimental arrangement consists of a discharge tube provided with a cathode, which produces cathode rays. Those rays are made to flow through two slits, and then it is made to flow through an anode, and it is made to fall on a thin gold foil. And the scattered rays from the thin gold foil are collected on a photographic plate. And the whole apparatus is provided with a vacuum pump so that electron energy will not be decreased. This is the experimental arrangement. Let us see in the words. So the experimental arrangement mainly consists of one discharge tube in which cathode rays are generated by an induction coil which is accelerated to a potential of 50,000 ohms. As I told you earlier itself, he conducted many experiments with electrons which are accelerated to high potentials. So in this experiment, he generated cathode rays by accelerating them to a potential of 50,000 volts. Now the fine beam is obtained by passing these through a slit S. So what are the cathode rays which are produced due to that discharge tube? They were made to flow through the slit S, which makes them as a fine beam and single directional. Those fine beam of cathode rays are made to fall on a thin gold film G, whose thickness will be in the order of 10 power minus 6 centimeters. So whatever the gold foil we are considering here, its thickness should be in the order of 10 power minus 6 centimeters. And the photographic plate is arranged at the end to collect or record the beam from the thin gold foil. And the distance from the gold foil to the photographic plate will be about 32.5 centimeters. This distance will be utilized to calculate the wavelength of those electron beams or the cathode rays. Okay, and the photographic plate, which is placed at the end of the arrangement, it can be moved up and down in front of the screen so that we can monitor the cathode rays before the photograph is recorded. Okay, and the whole apparatus is exhausted to a high vacuum so that the electrons may not lose their energy in collision with the molecules of the gas. This is all regarding the experimental arrangement for a GP Thomson experiment. Coming to the procedure, here what they are supposed to do is a beam of electrons of known velocity is made to fall on a thin gold foil, and those traversing from the thin gold foil, they were collected on a photographic plate. When the plate is developed, a symmetric pattern consisting of concentric rings about the center spot is obtained, which is as similar as the pattern which is obtained by the X-rays. So on the screen, you can observe the pattern which is obtained when the beam of electrons are diffracted from a thin gold foil, and it is recorded on a photographic plate. So you can observe that there are concentric rings which are like alternate black and white rings will be there. So coming back to the conclusions. So to prove that whether the pattern is due to electrons or the X-rays, what they're supposed to do is they had placed the whole apparatus in the magnetic field. And when the magnetic field is changed, the cathode rays are also deflecting according to the magnetic field, which proves that the cathode rays are the electrons, not the X-rays, because X-rays are not affected by magnetic field. So if the pattern is due to X-rays, definitely it should not be affected by the magnetic field. But whatever the pattern we are seeing here, during the change of field strength of the magnetic field strength, the pattern is also moving according to the field. So the pattern which is formed from the gold foil, it is due to electrons only, not X-rays. And the diffraction pattern which is formed at the photographic plate, simply it is due to waves only, because waves are the reason for the formation of diffraction patterns. So in in this experiment, Thomson concluded that electrons behave like waves, and the wavelength obtained by diffraction patterns well agrees with the de Broglie wavelength, whatever the formula we had used. Lambda is equal to 12.26 by root V Armstrongs. Using that formula, they had derived the wavelength of the patterns, and they agrees well with the de Broglie relation. And Thomson experiment clearly demonstrated that existence of matter waves. So whereas if the whatever the gold foil we had taken here, if it's a single crystal, hence we had obtained a continuous rings as the pattern at the output. But instead of using a single crystal, if you use a polycrystalline material in place of single crystal, what happens to the complete experimental structure? So again, they had conducted the same experiment by taking cathode rays from the discharge tube, made them to fall on a polycrystalline material through a slit, which makes it fine and sharp. When the rays get scattered or the diffracted by the polycrystalline material, again they had recorded the things with a photographic plate at the end. By developing that photographic plate, what they had observed is the pattern is very similar to the powdered diffraction pattern of X-rays. Again, to know whether the pattern is due to X-rays or the electrons, again they place the whole apparatus in the magnetic field, and by changing the field strength, they had observed there is a movement in the pattern which is formed on the photographic plate. So by that they concluded that the pattern is due to electrons, and electrons forms diffraction patterns, means electrons behaves like waves. And the wavelength of electrons was varied by changing the incident energy of the electrons, and the diameter of the diffraction rings can also be proportional to the Bragg's equation. So this is what they had done in their experiment to explain whether the electrons is having wave nature or not, especially in GP Thomson experiment. They had done the experiment only with the electron particles only, and he proved that electrons is having wave nature. Whereas in Davison-Germer experiment, we can purely say that all the particles which are in movement can be can have a dual nature. And finally, G.P. Thomson and C.J. Davison, these are the both scientists who had proved the existence of matter waves, and got Nobel Prize in the year of 1937. They shared it for their independent experiments, which proved that electrons show wave-like behavior. G.P. Thomson experiment and Davison-Germer experiment are the independent experiments for which they proved that electrons show wave-like behavior. And it is interesting that G.P. Thomson was the son of J.J. Thomson, who received Nobel Prize in 1906 for proving that cathode rays were actually particles called electrons. As we had a doubt that from the first slide itself, I am talking that cathode rays, electrons, cathode rays, and electrons. So cathode rays are nothing but electrons only. Okay, and this got proved by J.J. Thomson in the year of 1906, and he got Nobel Prize for the same invention also. Thank you.